Hello everyone, welcome back. This is Engineer Hussein Mwasapi, and in this video we'll be looking at methods that we use to find differential equations, with the aspect of us looking at the subtopic which involves the formation of ODEs, which are ordinary differential equations, or rather just say differential equations. Alright, so before we begin, do not forget to like and subscribe to the channel. Okay, so let's begin. Now, whenever you're looking at the methods that can be used to form differential, let's just say find a differential equation, it can be a bit tricky because they'll never really tell you to say use this method or that. It's just up to you to use inspection and know that I'll use this method. Alright, so method number one, I want us to understand the first method, which is called direct integration. Now, under direct integration, what you need to understand is that the entire goal, whenever you're being given a differential equation, is to find the function, the f of x, or rather, the y. This is our goal. So, say we have an equation which is in the form where we have a differential coefficient dy dx, and this is equivalent to a function f of x, or even just y. Given this, we can basically apply direct integration, because the differential equation, the differential coefficient rather, is equal to one function. It's not really equal to two functions, it's equal to one function. We have dy over dx. Remember, dy over dx simply means you're differentiating the y function, which is the f of x, because y is f of x, that's what I'm trying to say there. You're differentiating the y function there, d over dx times y is the same as d over dx times f of x. So you're differentiating the y function with respect to x, taking any other variable as a constant. So we're having the differential coefficient being equivalent to one function of x. We don't have a multivariable function. We're only having one function, which is the function of x. We don't have the function of x and y. So with this in mind, you can apply direct integration by finding the differential that can go together with f of x, in the sense that if I have dy over dx being equal to f of x, I can put everything that is having x on one side of the equation, and I'll say dy is equal to f of x dx. I have just applied cross multiplication at this point star. So when I have this particular pattern, I can apply direct integration. I can integrate dy, and I can also integrate the function of x dx. If you integrate dy with respect to y, you get the y function, because it's like you're having a coefficient of 1 there. So the integral of 1 is the variable y. So you have y being equal to the integral of f of x dx. This is like the basic concept. You're having a differential equation, differential coefficient being equivalent to one function that is dependent only on x. Let me show you with examples. Say we have example number 1. So we have x dy over dx is equal to 3 minus 2x squared. So we want to find the value of y, or f of x, or rather they will just say solve the differential equation. So to solve this differential equation, you have to look at the equation you have. How many variables are here? You're having the variables of x to be mostly present. So what are we supposed to do? We're supposed to put all the x's on one side and make dy the subject of the formula. So whenever you only have like, what can I say? What I'm trying to say is that whenever you have dy and dx, of which you only have one f of x present and one differential equation, I don't even say one, depends with the type of equation that you might be given. All you have to do is to make dy the subject of the formula. So make dy subject, then integrate. So what I'm going to do is that I'll cross multiply. So I have x dy is equal to dx times 3 minus 2x squared. So we understand that this can also be written as x dy is equivalent to 3 minus 2x squared, then dx at the end. Now we want to make dy the subject, so we have to divide by x to both ends. So dy is equal to, now this can be written as 3 over x minus 2x squared over x, then dx. Can be simplified furthermore as 3 over x minus 2x dx. Then you can basically integrate. We can integrate independent of the terms. I can integrate this one separately and the other one separately. But the best way is to do it all at once. So you introduce the integral sign on both ends of the equation. So the integral of dy is equal to the integral of 3 over x minus 2x dx. Now we know that the integral of dy is basically just y. And now I have to find the integral of the other remaining part. So we're trying to integrate according to the linearity property. We can say the integral of 3 over x dx minus the integral of 2x dx. You can always push out the constants. You can always pull out the constants. This will be 3, then the integral of 1 over x dx minus 2, the integral of x dx. Now, what's the integral of 1 over something? So y is equal to 3. The integral of 1 over something is basically ln of something. So ln of the absolute value of x. Remember, whenever you have the integral of 1 over something, then dx, be mindful that this will always be equivalent to ln of the absolute value of something. Never forget. So we have 3 ln of the absolute value of x, then minus 2. Remember, this has a power of 1, so you have x. Remember, increase the power by 1, then divide the entire term by the new power. So you have the power 2 divided by 2. Then remember, we have no initial conditions, so we're going to have the presence of an arbitrary constant c. So this will be plus c. So this will be y being equal to 3 ln of the absolute value of x minus 2 there, 1, 2 there, 1. So you have x squared plus c. This is basically our differential equation. And that's how we go about solving it. All right, this might look like a handful at first glance, but the more you practice these problems, the better you become. Let's look at another example. Now, say we have dy over dx is equal to 5 x squared plus cos of 3x. Now, as you can notice, you are seeing that these are all dependent on x. They don't have y there. That's why it's best to use what? Direct integration. By taking x dx the other side of the equation. So I have dy being equal to 5 x squared plus cos of 3x, then dx. And by applying the integral sign on both ends, we'll have this 5x squared plus cos of 3x dx. Then the integral of dy is basically just y. Then integrating 5x squared, all right, let's write it like this: integral of 5x squared dx plus the integral of cos of 3x dx. All right, so this will be y being equal to 5, then the integral of x squared dx plus the integral of cos of 3x dx. So we have y, which is equal to, be mindful, this will be 5, then x to the power 3 over 3. Now, what is the integral of cos? What is the integral of cos? So basically, for cosine, what you have to understand is this. Let's say data. So we're trying to integrate, let's say, cos of 3x dx. So we're going to use the u substitutional method. We'll let the argument be equivalent to u. So let u be equal to the argument, which is 3x. Then we'll differentiate u. So we look for du over dx, which is going to be 3. Then what we do is to make x a separate formula. So since these are inversely related, they can easily just swap. So we have dx being equal to du over 3. Upon having that, we can say that this is now as integral of cos of u dx is equivalent to du over 3. Now remember, according to the properties of integration, we can pull out the constant. So this is like 1 over 3, the integral of cos of u du. So integrate cos u with respect to u. Now what is the integral of cos? The integral of cos is negative sign. So we have 1 over 3 of negative sine u. So remember that the value of u was found. So this will be minus 1 over 3 sine of the argument 3x. And that is how you integrate a trig function such as cos. So you have minus 1 over 3 sine of 3x. Remember, we have no initial values. So we add an arbitrarily constant c. And this is our final answer. Now, for most of you who do not really prefer seeing fractions, you can always multiply throughout the equation by 3. So you have y being equal to 5x squared, cubed, minus 1 over 3. This is over 3 as well. Sine of 3x plus c. Then multiply everything by 3. So therefore, we end up having 3y being equal to 5x cubed minus sine of 3x plus 3c. So this would basically be our final answer. All right, let's move on to the last example. So take for instance, we have e to the x dy dx is equal to 4. Now, what I want you to understand is that when it comes to direct integration, always look for what you need. Always look for the f of x function. So the key is to create the f of x function. Once you create the f of x function, then you can take dx outside. It could be also f of y. I'm not really saying that it's always x. It depends with the variable that we're giving respect to. So in this case, what we can do is multiply the entire equation by e to the x. So I have e to the, by the reciprocal of e to the x. So I have e to the x dy over dx is equal to 4. So we say times its reciprocal, which is 1 over e to the x. So we know that this will cancel out with that, and we'll have dy over dx being equal to 4 over e to the x. Now, this becomes the f of x that we are looking for, or that we're using rather. So we do cross multiplication, and this would be dy being equal to 4 over e to the x dx. Applying the integral sign to both ends of the integral of 4 over e to the x dx. The integral of dy is y being equal to, we can apply the constant multiple rule, and we have 4 integral of 1 over e to the x dx. Now, we can't really say 1 over something is equal to ln of something in this case here. Now that will not make sense at all. So the best way is basically to change this to a negative index. So you have y being equal to 4, then the integral of e to the minus x dx. Now be mindful that the integral of e to the something is always equal to e to the something divided by the derivative of something. The integral of e to the something is equal to e to the something divided by the derivative of that particular something. So we have y being equal to 4. Then remember, repeat e to the something divided by the derivative of something. What's the derivative of minus x? Yes, it's minus 1. Then remember, we have no initial conditions. We haven't been told that y is equal to something and x is equal to something. So we're just going to say plus c. So this is basically y being equal to minus 4 e to the minus x plus c. So your answer can end here, or those who like to show off, we can say this because we can't end just here, guys. Come on. So it's going to be minus 4 over e to the x plus c. So that is how you solve questions where you have to solve a differential equation under the method of direct integration. Alright, so thanks for watching. If you have any questions, you can reach me up on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and let us strategize before becoming a statistic. Let's try and push for that. A+.